It surprises me when BMS, BAS project managers get surprised when the BMS commissioning program gets compressed. So the BMS program for commissioning is supposed to be 3 months long, and it gets compressed to 1 month long. So over the last 3 years, as they were digging holes and there were delays from weather and all the preceding trades, mechanical, electrical, fire, hydraulics, they were all running a bit more late through the years, and power came on late, and air and water balancing started late. And as we're going later and later and later, and the end date didn't move, the BMS commissioning got compressed. It surprises me that BMS companies get surprised by this. You should not be surprised by it. That job that you're working on right now, the BMS commissioning will be compressed. That job next year, the BMS commissioning will be compressed, and the next year, and the next year, and in 5 years, and in 10 years. The BMS commissioning program will get compressed. Do not be surprised by it. I'm pretty sure, and I used to do this too when I was a young project manager, you'd go to site to that very first commissioning meeting, you'd sit in there with the builder and the commissioning agents and the other trades, and you would find out that the BMS commissioning program got compressed. And then I'd walk back to the office, throw my bag down angry, and I go and talk to the branch manager. I'd be leaning on his desk in the office, say, "You're not gonna believe what happened. I've just been to the very first commissioning program. Guess what happened? What do you think happened?" And my boss would say, "The commissioning got compressed." And I'd say, "Yeah, it got compressed. These fools, how do they think we're gonna commission the BMS in 1 month? They want us to work double shifts, a day and a night shift. They want us to get to double our resources. We can't do that." We've all had that moan. What surprises me is that after all these years, we still haven't learned our lesson. We do almost nothing in the preceding phases building up to commissioning. We do nothing in the sales phase, nothing in the design phase, nothing in the engineering phase, nothing in the installation phase. We get to commissioning, and now we want to start doing something about it. It's too late. If you get to commissioning and you've got a plan, it's too late. And I think our current plan for dealing with commissioning programs is this. We get to commissioning and everything's compressed, and every month we write a letter to our client and say, "By the way, we were supposed to be commissioning in the chiller plant room this week, and we can't because air and water balancing is not finished. We are in delay. Next month, we're supposed to be commissioning the roof plant room, basement plant rooms, and we're not commissioning, we're in delay." So in the BMS industry, it feels to me that the only thing that we actively do to mitigate compressed commissioning programs is to protect ourselves from financial penalties. But we don't do much in the build up to this. And I think another part of this is that just generally with all sorts of things, like there is an unlimited list, a never-ending list of problems in our industry. And I think that these problems are not getting solved because we are all waiting for somebody else to solve our problems. We're always waiting for the building owner to say, "No, there must be 3 months of commissioning. You can't compress the commissioning." Or we wait for the builder, the head contractor, to do something to protect our precious commissioning time. Or we want the consultant to do something. We're waiting for somebody else to do something to protect our commissioning time. Let me tell you something now. All those people that we're waiting to help us to solve our problems, they've got their own problems. The building owner, the developer, right at the top of the food chain, they probably don't even know what a BMS even is, for a start. And secondly, there's 3,000 people from all these different commercial offices where their rentals, their tenancies are expiring. There's 3,000 people moving into this new beautiful commercial office on that Monday. They've got nowhere else to go. We can't push the date back. They've got to go in on that Monday. The mechanical consultants, they've got their own problems to deal with. The BMS is not a thing they've got time to sort of worry about. Everybody else that we're waiting to solve our problems has their own problems. We need to solve our own problems. So in today's video, I'm gonna jump on that microphone and that camera. I'm gonna screen share a presentation that I did in Australia last year at the AIRAH Australian Institute of Refrigeration and Air Conditioning, at the AIRAH Future of HVAC thing that happened. So I'm just gonna run through the exact presentation that I did on that day. Right, let's get into it. Good morning, everybody. It's so great to see you, and I'm so happy to be here. That is not at all what happened. When I did this presentation, it was a live presentation. I walked in this room, and this room was like 5 times bigger than any other room I'd ever presented in. And I had to walk up onto a really big stage. And usually there's like a square room, and I've got 50, 60, 70, 80 people that are normally facing forward. They're facing forward at me and I'm presenting. In this room, it was a very big room, and people were were there the whole day, so they were eating and doing different things. So everyone was sitting at these big round tables. So there was just like these big round tables all over this room, walking up on a stage. Everything was recorded. It was very professional. So yeah, I was very, very nervous that day. So I did not go up there and go, good morning, happy everybody. I was a nervous wreck. So today you are lucky enough to have me here in my home office on Saturday morning, all calm and relaxed. Right, let's get into this. We are building buildings faster than ever before, but we generally haven't changed how we build buildings. In my opinion, I have a feeling that we're at a crossroads right now, especially with all this technology that's been integrated into buildings. We either have to slow down the construction phase and do things properly, or we have to spend a lot more money or do something completely different. But either way, we cannot continue the way we have been for the last 20 years. And in my opinion, we cannot slow down the construction phase. That won't happen. We're not going to get more money to spend, so we have to change how we build buildings. In today's presentation, I'm going to talk through a few things that I've personally done in my career, and hope you can get a few ideas of things that you could improve or change in the BMS or the BAS on your next project or in the future. So what I want to first do is I want to talk through how we usually install the mechanical system and the BMS, so that we're all on the same page, and most of you should recognize that or agree that that's how we do it, or at least similar to that. And then I'll go through and talk about a new way of installing the BMS. So what normally happens, so here's a big plant room. On the top left, we've got 2 boilers and 2 boiler pumps. On the top right, we have a chiller plant room, 3 chillers, 3 chill water pumps, and 3 condenser water pumps. And this very large plant room at the bottom, the air handler unit plant room. I've got 1, 2, 3, 4 air handler units, and I'll zoom in this later on, but basically this is the supply duct, the return and outside air ducts, some filters, heating, cooling coils, and a few doors on the side here. So this is a top view of a typical boiler cooling air handler unit plant room. Now what happens is usually very large mechanical equipment is installed very early in projects. You can't carry a chiller down a flight of stairs into the basement. So usually before the slab for the plant room goes on, they would install this big equipment in there, or maybe this wall over here wouldn't be here, and they'd slot these boilers in here and then build the wall afterwards. But either way, large mechanical equipment is sitting in plant rooms for 2 or 3 months and nothing's happening to them. You must be used to walking through plant rooms and just seeing air handler units sitting there for months doing nothing. So the first thing that happens is that the mechanical contractor usually has priority in the plant room. So they start installing their heating hot water pipework to the boilers, their chill water pipework and condenser water pipework to the chillers, and they start putting all the air handler unit ducting through the plant rooms, and they'll connect that up to all the air handler units and exhaust fans in different systems. So the first person that has priority is the mechanical contractor, and that's because a lot of the other electrical containment is usually installed off of pipework and ductwork. So on those threaded rods from the ceiling that come down that hold the pipework and ductwork, often we'll install our electrical tray or ducting off of those hangers. So we've got to wait. And my rule of thumb generally as a project manager was that when the mechanical install was about 80% done, 80, we would then start going in and doing some rough-in for the BMS. But through this whole part here, for the 2 or 3 months that this equipment sat in the plant rooms doing nothing, and for this first month or so that mechanical is working, the BMS is waiting. We cannot continue. We can't do our work until the preceding trades progress further. The next person that has priority in the plant room is the mechanical electrician. Now this is probably a bit different in Australia. We have the mechanical contractor and the BMS contractor. We also have a mechanical electrician. In most other countries, I think that the BMS company is also the mechanical electrician. So here I've got this mechanical services switchboard. In other countries, that's a motor control panel or a motor control center. So the mechanical electrician has second priority in the plant room. They install the mechanical board and they start running all the mains power feeds out to all the equipment. So they install all the variable speed drives on the air handling units and on the pumps, and they start running the main power feeds. And they're hanging their electrical containment off of the pipe and duct. But again, the BMS contractor is waiting. Now, sometimes the install contractor will start roughing in some cabling on these air handlers, but the cables will just be rolled up and waiting. They might do some install here and roll up the cables, roll up the cables, roll up the cables. Maybe in the boiler plant room, start doing some roughing, rolling up the cables, because they can't get these cables all the way down through these common areas, because these common areas are very busy with pipe fitters and people doing the duct and the mechanical electrician. The BMS company does not have priority yet to work in the plant room. The BMS company is normally waiting. And then eventually, when the mechanical has progressed and the mechanical electrical has progressed, then it's the BMS company's chance to work in the plant room. So we install this centralized BMS panel. In Australia, we normally have our panels separate from the mechanical boards because it's two different companies. But in a lot of countries, for sure, where the BMS is also the mechanical electrician, you'll be putting the BMS controllers in the mechanical boards. There are some companies in Australia that do that, but generally in Australia, the BMS control panel is separate. So we have this centralized BMS control panel that we've got to get 150 cables to from the boiler plant room, the chiller plant room, and the 4 air handling units. Now, in previous years, what used to happen is when the mechanical electrical was finished, the BMS installer would have 2 or 3 weeks to finish off the installation, get all their cables down these common congested areas back to our centralized, and centralized is an important word, our centralized control panel. Problem nowadays with all the pressure on construction and to get jobs done, usually what happens is when the very last power feed is connected to the variable speed drive, mechanical wants to power up these boards and start air and water balancing because they're a month late. So what happens is the BMS installer is under extreme pressure to get their cables in because there's just no time to even do the BMS installation properly. For a lot of you, hopefully that's quite similar to how you do it. The BMS installers are waiting to get our chance. And when we get our chance, there's a very small window to finish our work off properly. So now I want to talk to you about a different way of doing this and a new way to design, install, and commission the BMS. And I'm calling it distributed power and controls, where in this example, we have centralized power and centralized controls in one central location. Now I want to distribute that. And this is a photo that I personally took in around about 2009 when I was doing BMS design in London. So I'll be talking you through now the method that I was taught how to do this. So the first thing I want to do is just start all over again at the start. So remember I said that in these big plant rooms, the mechanical equipment is installed 2 or 3 months before anything happens. You just walk past these plant rooms, that equipment just sits there doing nothing, and we're waiting for the building to progress to a point that this plant room is now ready to be worked on by mechanical, electrical, and the BMS. But we don't have time to wait. There isn't time to wait. We've got to try and do something differently. And the first idea here is that this mechanical control panel is a massive bottleneck in the BMS. And if we can get rid of this mechanical control panel, it's going to speed things up really quickly for us. So the first thing we're going to do is we're going to distribute the controls. So before we had this centralized control panel with 10 or 20 BMS controllers in there, we're distributing all the controllers out to where the equipment is. So in the boiler plant room, we've got a BMS panel with those controllers in. In the chiller plant room, we have a BMS panel with those controllers in. And on every single air handling unit, we have a very small panel with just one controller in, and we're distributing the controls across. And I've also shown here that the variable speed drives are being installed at the same time. And then we distribute the power. So rather than having a centralized, very large 5-meter mechanical control panel, which I'll just pause for a second. My experience was, a long time ago when I used to do this, is that it would take about 3 months from the start of just starting to think about the mechanical control panel, design the control panel, get it approved, get it built and sent to site on a concrete plinth and install. That's a 3-month process. Straight away here, we've cut that out because these are standard distribution boards. They're not mechanical boards. There's no handoff auto switches on there. It's an off-the-shelf distribution board with some 3-phase circuit breakers in there. You could buy them tomorrow and in 2 days' time, screw them onto the walls. So that's really quickly to do that. We're not wasting all this valuable, precious time designing this mechanical control panel, this centralized panel. And here on the air handling unit, we've got a little mini distribution board, like a mini, almost a domestic looking thing. It's got a 3-phase circuit breaker for the supply fan VSD. We've got a 3-phase circuit breaker for the return fan VSD. There's a single-phase circuit breaker for the BMS control panel. You could have a single-phase circuit breaker for the AHU lighting. If you have a runaround pump or a humidifier, there's a single-phase circuit breaker for that as well. So we have distributed all the controls and all the power throughout the plant room and not have centralized systems. So here's our air handling unit. So, months and months in advance of it normally being installed, you just roll up to the AHU with a trolley, you screw the 2 VSDs onto the AHU, this BMS control panel with this one controller in, this little distribution board, and you can start pre-wiring a lot of this AHU now because you're not wiring back to a central location very far away. And if you're buddies with mechanical and you say, listen guys, can you just please put a meter of pipe work, get the heating and cooling valves installed for us earlier than you would normally have, please? Then we can wire our 24 volts AC and our 0 to 10 volts DC signals to the actuators. Maybe you could try get the outside air damper and the minimum outside air dampers installed. You put the actuators on. So you get your supply air temperature, pressure, humidity, return air temperature, CO2, volume, airflow stations, the whole thing, right? Get that all roughed in there. Now here I've got the second dot point of here. It says temporary commissioning, and this is where the whole thing falls into place. If you want to do temporary commissioning in this plant room, the entire plant room has to be fully complete to power up this power board and power up these controls. The electrical union is not going to allow you to power up a plant room if there's people working all over the place. So in this situation, you can just put some barriers up here and you can get a temporary power feed onto this BMS panel. So put a temporary power feed onto the BMS panel, like a 24 volts AC power feed, and you can power up the controller, download the program, address the controller, and then start pre-commissioning, driving the valve actuators open and closed, getting the sensors online. Like not everything, some things won't be on here yet, but as much as you can. And if you have a network controller on that trolley, you can power up the network control temporarily, suck all these BMS points into the network controller, and you can commission the database, the alarms and trends, the graphic could be on your laptop, you could check the binding, you could do the whole thing. There's a massive amount of pre-work that you could do on this temporary commissioning. Now, I did that. What I haven't done is I never powered up the distribution board temporarily, but I'm just suggesting now, as I'm thinking this through, if you temporarily powered up this distribution board, I'm not saying you could do this, I'm just sort of talking through the idea. You temporarily power this, then you power up the VSDs. Don't turn them on, like don't run them, just power them up. You could set the addressing and get them online to the BMS controller and your temporary network controller, get that all commissioned. You could do the high-level interface, map all the points back. You could even probably input off the motor nameplates, the voltage, current, the frequency, the RPM, and maybe, I'm just making this up, but just turn the VSD on, just like 2 or 3% and just do a rotation check. Is the fan turned the right way, then turn the power off again. In Australia, we often have temporary power supplies on our floors, like when there's no power, to power lighting and drills and the equipment you need to build stuff, right? So you might be able to temporarily power this up. Perhaps not. Maybe I'm pushing it a bit too far there, but you certainly can power up the BMS, even if you just used a little, one of those small like UPSs, those small ones you get, like portable UPS. You just put in your trolley, you power it up overnight, and now you got a UPS power supply to power up your 24 volts transformer to power up this panel. You don't even need to have a mains temporary power supply. Just have a big UPS. Have 10 UPSs on site, power them up overnight, and the commissioning techs carry them around with them and deplete them and get a new one after lunch. Same thing for the chiller plant room. Lock the door, put a big sign on the door, temporary commissioning underway, power up the BMS panel temporarily, do some stuff in here. I think it's a bit more difficult with the chiller plant room because you need a lot of containment, electrical containment to be installed all around you by others. Maybe this wouldn't work so well in the main plant rooms. There's only one chiller plant room, one boiler plant room, one cooling tower plant room. If you didn't get much of this done, so what? You've got 50 air handling that you can do. So, and over here now, so we installed the stuff on the AHUs months before. We temporarily powered the AHU because we now made it easier to temporarily power one part at a time, one part at a time, one part at a time. And now later on, as the mechanical progressed with their pipe work and duct work, and the mechanical electrician perhaps progressed, now you've got to get a network around the controller. So you quickly run a network cable to each controller. Of course, it's still across the whole plant room, but that's a much less work. And also, you've already commissioned much of the inputs and outputs. You just get the network installed now. Throw like a Wi-Fi router on there for the rest of commissioning and fine-tuning and witnessing and for service for the next 20 years. I don't know why we don't do that. It's very obvious. And then for the fire alarm system, you can run the fire interlocking cables around to these control panels, blah, blah, blah. Now this mechanical distribution board here, note I didn't call it a mechanical services switchboard or a mechanical control panel. I called it a mechanical distribution board. All that it is a standard off-the-shelf distribution board, just with circuit breakers. There's no handoff auto switches or undervolt fault lamps, and you're providing a mains feed to each one of the distributed mini distribution boards. So you've still got some work to do. You got to distribute the network throughout the plant room, the fire interlocking through the plant room, and that last bit of power. But your install's like 80% done. Your commissioning is 80% done. You are miles ahead of where you would have been doing the traditional way. So here's an example of like a commissioning trolley. So, here's your AHU, you're temporarily wiring it. There's a box on there. You push your trolley up. There's a massive screen in here. Got your laptop in here, keyboard and mouse. Now, you might have a temporary server in here and the network controller for this plant room. So you can get that all online, the whole thing. AHU1, you commission the inputs and outputs, get the graphic online, the trends built, the alarms built, all mapped through, the time schedules, everything. Move across to AHU2, AHU1 goes offline, AHU2 comes online. You just work through the whole thing. You're not just doing point-to-point commissioning. You're doing all of the commissioning, bang, in one shot. Got some water down here if you get thirsty. Got some Christmas lights up here, love it. And maybe inside here you've got a transformer or your UPS has your power supply nice and locked. And in the afternoon, you lock these doors, you pull this flap down, everything's safe, you leave it there until the next day. You just push this thing through the plant rooms. 2 or 3 months before mains power would have been there, you just push your trolley into this plant room. You're there for 2 or 3 weeks, push your trolley in the next plant room. This is not rocket science. I'm sure a lot of you are thinking right now, oh, that makes sense, like we should do that. This is not rocket science. This is not artificial intelligence or machine learning or the Internet of Things. This is just like, what is our problem? We're starting install too late. We're starting commissioning too late. We don't have time. Let's shift everything forward 3 months. That's all it is. Now, I didn't make this up. I've done this before. As I said before at the start of this presentation, this is a chiller plant room that I did. The first one I ever did in 2009. If I'd stayed in London, because I came to Australia in 2010, if I'd stayed in London, I would have done like 10 or 20 of these by now and perfected it. This was my first one. So this was a chiller plant room that was broken up into 4 separate skids. So it's 1, 2, this is the third piece. If I remember correctly, we designed the plant room for months and months and months, using like 3D programs. I used to walk through the plant room and see where the pipes went and where can I put different things. And then they built these skids off-site at a factory, and they came on a truck. And if I remember correctly, 3 days after these skids were delivered, and the pipe works were all flanged up, and there was a roof put on top here, and the main power feed came on. We started water balancing 3 days after these things were delivered to site. We also did a boiler plant room as well, like this. So here I've jumped onto the back of the truck and took a photo in here. Now we still had handoff auto switches, which I wouldn't have anymore. This is because to try and convince the consultant to do this, he was up for it, but he was still nervous about the handoff auto switches, so we kept them on this job, but we would normally remove them. Here's a big power distribution board. He has 2 distribution board, 2 Danfoss variable speed drives at the back there, pressurization unit, some pumps, heat exchangers, lagging, everything's down here. There's some power wiring. So we never ran the instrumentation cabling. The next time I did this, I would have tried to work out how to do all the instrumentation cabling, and I would have had a small control panel on each of the 4 skids so I could completely wire the power and controls completely in one quadrant and not have cables cross between the 4 skids. I also tried to do off-site manufacturing of air handling units. So I caught a train up the north of England, and I went to the AHU manufacturer's facility and met with them and walked the line to understand how do you build the AHUs and how does it roll off, how long can it stay here before it goes. So this was all installed at the factory, duty standby, supply and return fans, and here's my control panel here. To be honest, it turned out that this wasn't actually worth it. We stopped doing it. It's really difficult to prefabricate controls offsite on AHUs because the AHUs get delivered in modules and get bolted together. So we were trying to do different types of cabling methods with plugs to plug through, which is too hard. A bit of damage also happens on the AHUs. What I did work out was that the AHU is sitting there for 3 months early anyway. Like, look at this one, still is on a block, a wooden block. There's wooden blocks on here. That's how early this is. For AHU offsite manufacturing, it's not worth it. The AHU sits there for 3 months. Just get 2 electricians with a trolley, push the trolley up, put the VSDs on the isolator, just start the installation with the power and controls 3 months early. I didn't have a lot of success doing offsite manufacturing of air handling units, but we did do it with the chiller and boiler plant rooms. Here's a photo of that control panel. You can see how old this was as Andover Continuum. It was supported then, now it's obsolete. Around about 2008, 2009, I did this. I designed this control panel. This control panel is fully loaded for 52 different air handling units. So we didn't have different AHUs, different control panels for different AHUs. There's just 52 of them exactly the same. If an installer went into a plant room and there was 4 AHUs there, walk downstairs to the storeroom, grab 4 AHU panels, screw them onto the AHUs, don't care which panel goes where, they're exactly the same. So, and this little space over here was left here because the operating theater had duty standby supply and return fans with humidity controls, and I couldn't fit all the points on here. I didn't want to have an expansion module for nothing on like many AHUs. So for the operating theaters, the installers would just put 1 expansion module onto here for the humidity controls and the extra fans. But basically this one AHU does everything. Now a lot of people would think, oh, but Bryce, like, you don't need all these relays for some of the smaller AHUs. You have a smaller controller in there, try to save money. Let me tell you my experience. The thing that kills projects financially is labor hours, commissioning hours, design hours, engineering hours, project management hours. That's what kills profit. Material costs, in my opinion, in my experience, don't kill the cost that much. An extra controller costs like, $500 or whatever it is, right? So some of the stuff wasn't required, but at least I had this one AHU. So I went to the panel manufacturer. That's actually, hold on a sec. There's my multimeter. That's the exact same one over there. I've still got it. My father worked on the oil rigs in like North Siberia and the west coast of Africa off the Congo. So when I was a young kid in South Africa growing up, my father worked on oil rigs. When they used to build the rigs, they used to take all the tools with them. So my brother and I were very young and we had 2 very expensive multimeters. We were like the heroes on construction sites, the best multimeters for these kids on site. So I went to the factory. I tested this control panel, every single wire. I tested every wire, every relay. I downloaded a little dummy program into here. I made sure this was perfect. I spent like 4 hours testing this panel. Then I gave the panel manufacturer approval to build another 51 of those. If we want to build faster, cheaper, and layer on technology with less resources, less people, less humans, then we must do something different. I'm not going to lie, that's not easy. All right, on that hospital, I think I worked in that hospital like 40 hours a week for 12 months, just doing the BMS design, nothing else, just doing the design. I spent a lot of time doing it. And also in the north of England, there was another person that had done that for a hospital. So I went up to the north of England, met with them, walked around their hospital, saw what they did, came down to the south of England, had a crack at it myself. So I had a bit of help with it. What I'd suggest you do is do not try and do that on a big job. Just start and do 1 step at a time. So for example, in Australia, it's completely ridiculous. You wouldn't believe this. But in Australia, we still provide mechanical control panels for terminal units. So on level 10, you got the electrical riser, you open the cupboard, there's an orange board there, hand-off auto switches for fan call units or heat pumps. Complete waste of time. It's a locked door in an occupied area. There should not be a mechanical control panel. It should not be there. It should be removed. So start off by removing mechanical control panels, mechanical services switchboards from terminal unit applications. Do that first. Second thing you might do is wait till you get a small job, like a little 2-level shopping center, a little 15-story B-grade building. Try those ones first. Maybe don't do the boiler plant room or the chiller plant room or the cooling tower plant room. Let that just be normal. Big mechanical control panels, hand-off auto switches, all traditional, but in the air handling plant room, Just try the AHUs first. Distribute the power and distribute the controls for the AHUs first. Get that done. Then move on to a job that just has 2 air-cooled chillers. Do that. So it's one step at a time. It's not easy to do it. The other thing is that it's probably too late to start talking about this on a real job. It's too late. So maybe if you're a BMS company, go and talk to a mechanical contractor that you buddies with and go float this idea past them. Go there, do a few designs, workshop a few ideas, get them on board, you know. Maybe they can try and leverage this to try and win a job for themselves. I have this sort of idea that, you know, we're always trying to, you know, win jobs by building buildings cheaper. So the developer, the main contractor, the builder will go into a tender for $1 billion project and they're trying to win this job on the lowest price. That's what we do, right? But what happens if the builder goes into a meeting, into the tender with the client and said, listen here, we're going to build this building for $1 million. We're not the cheapest, but we'll finish this job 1 month earlier. And then the owner's thinking, whoa, 1 month? It's a 50-story commercial office. I can try and get tenants into 50 floors of commercial office. I get tenants in there and earn rent 1 month earlier. That's big bucks, bro. That's a lot of money, that. So we need to maybe try and, because this whole thing, okay, let me pause for a second. Removing the mechanical control panel, gone. It's not about saving money. Like you sort of save money, but you got to spend a lot more time on design and coordination. There's a bit more money to spend on the fire interlocking part and blah, blah, blah. This is not about saving money. This is about building faster. It's not about saving money. It's about building faster. Can you get the BMS installation started 2 months earlier? Can you get temporary commissioning started 2 months earlier? Can you finish the job 1 or 2 months earlier? That's what this is about. It's about de-risking practical completion. Because let's be honest, like on these big jobs, what hurts you the most at the end? It's not mechanical, electrical, lights on, power's there, pumps are running. It's always the extra low voltage trades like the BMS or the BAS. Those are the things that add risk into practical completion. That makes us miss deadlines. That makes big builders pay financial penalties for the job not being finished. This is about starting install quicker or sooner, starting commissioning sooner, creating more time for us to do commissioning and doing a better job. This might even allow us to get the technology stuff to work. Get the BMS built quicker, the database done properly, the object naming conventions properly, export that up to the cloud, technology, all that sort of stuff. That might work. That might work. It doesn't work now because the BMS is not finished at practical completion. It's not finished. Walls are painted, power and lighting, the doors work, the lifts work, the BMS is not finished. The control system is not finished at practical completion on big jobs. That's it. I hope you got something out of this. Like and subscribe, and I will see you the next time I feel like giving up a Saturday. For you guys, I got your back.